In this video, I want to show you some more examples about partial fraction decomposition method. As the first example, we want to see how we can write the expression x to the 2 plus 2x minus 4 over 2x to the 3 plus 3x to the 2 minus 2x in terms of simpler fractions. First, note that whenever you want to write any rational function like this in terms of simpler fractions, first you have to check that the degree of numerator is less than the degree of denominator. If the degree of numerator is greater than or equal to the degree of denominator, then first you have to do the long division. Then when the degree of numerator is less than the degree of denominator, you can apply the partial fraction decomposition method. This is very important and you should not forget this. Here, the degree of numerator is less than the degree of denominator. And right away, we can start the process. Before we solve this question, let me show you an example that we cannot start right away. For example, suppose we have something like this. This is a rational function. The degree of numerator is 3, but the degree of denominator is 2. And because the degree of numerator is bigger than the degree of denominator, first we have to do the long division to make the degree of numerator less than the degree of denominator. Later in this video, we will see examples like this. But for now, let's focus on this example. Because the degree of numerator again is less than the degree of denominator, we start factoring the denominator. Here the denominator is 2x to the 3 plus 3x to the 2 minus 2x. Immediately we can see that we can factor x because x is in all the terms here. If we factor x, then we have 2x to the 2 plus 3x minus 2. And now we have to factor this quadratic expression in the bracket. If you remember, for factoring quadratics like this, that the coefficient of x to the 2 is not 1, first we have to multiply this coefficient by this number. 2 times negative 2 is negative 4. Then we look for two numbers that their product is negative 4 and their sum is 3. So we look for two numbers that their product is negative 4, their sum is 3. Those numbers are 4 and negative 1. So we write the expression in the bracket in the form of 2x to the 2 plus 4x minus x minus 2. Again, why we did this? Because negative 4 is the product and 3 is the sum. Those two numbers that their product is negative 4 are basically 4 and negative 1. And their sum, the sum of these two numbers is exactly 3. Now, we do a grouping. We group these two. If we factor 2x from these two, then we have 2x times x plus 2. And if from these two we factor a negative, then we have negative x plus 2. Then we can factor x plus 2 here. So then we have x plus 2 times 2x minus 1. So finally, the factored form of the denominator is x times x plus 2. So we have x times x plus 2 times 2x minus 1. The first step is always factoring the denominator. And we rewrite the numerator. Now that we have factored the denominator, we can write the partial fraction decomposition. Because in the denominator we have 3 factors, so the partial fraction decomposition also, in the partial fraction decomposition we have 3 fractions. In the first fraction, the denominator is x, then we have x plus 2 and 2x minus 1. And in the numerator we put the unknowns a, b, c, the coefficients that we have to find. Now we have to start finding a, b, c. For finding a, b, c, we multiply both sides of this equation. Attention, this is equal to this. And we want to find a and b and c such that this fraction equals to the sum of these fractions. So basically we have an equation, and for finding ABC, we multiply both sides by the denominator, by this, because we want to get rid of the fractions in the both sides. Later, after we finish finding ABC, I will show you another method that can be helpful for some of its students for finding ABC. And sometimes the students find that method easier. But for now, let's start finding ABC with the standard method. We multiply both sides by x times x plus 2 times 2x minus 1. If we multiply both sides by, again, this expression, in the left side, because we multiply this fraction by this denominator, this cancels completely. And in the left side, we have only x to the 2 plus 2x minus 4. But in the right side, we have a times x plus 2 times 2x minus 1. For b, we have b times x times 2x minus 1. And for c, we have c x times x plus 2. If we multiply the brackets, if we multiply these two brackets, if we multiply x in the bracket, and if we multiply this x in this bracket, and we simplify, then we have x to the 2 plus 2x minus 4 equals a times 2x to the 2 minus x plus 4x minus 2. We have b bracket 2x2 minus x, and then c bracket x2 plus 2x. I will show you all the process of simplifying these. Of course, you can do this process faster, but here I show you step by step the process of finding ABC, because for some students this is a little challenging. And then we have again x2 plus 2x minus 4, it should equal to, now attention, here we have 2x to the 2, 2x, b times 2x to the 2, and cx to the 2. So for x to the 2, the coefficient of x to the 2 in the right side is basically 2a plus 2b plus c. What is coefficient of x? Here, if we simplify 4x minus x, it's basically 3x. And 3 multiplies by x, so the coefficient of x is 3a. b times negative 1, b times negative x is negative bx, so we have a negative b as coefficient for x. And finally, we have c times 2x, so the coefficient of x is also 2c. And finally, let's see what is the constant in the right side. The only constant that we have in the right side is just a times this negative 2. So at the end, we have a negative 2a also here. Now, we can write our system of equation for finding ABC. How we do that? We look at the left side and the right side, and we equate the coefficient of every term with the corresponding term in the other side. For example, in the right side we have negative 2a, which is the only term that is constant. And in the left side, the only constant is negative 4. So, negative 2a should be equal to negative 4. Negative 2a equals negative 4. Then, compare this with this. The coefficient of x in the right side is 3a minus b plus 2c. In the other side, the coefficient of x is 2. And then the coefficient of x to the 2 here is 2a plus 2b plus c. And in the other side, the coefficient of x to the 2 here is 1. Now we have our system of equations, 3 equations with 3 unknowns, and we can solve this system of equations. Here we are a little lucky that we have this simple equation, this first equation, and from here simply a is negative 4 divided by negative 2, or a is 2. Now that we have the value of a, we can substitute this value in the other equations to make those equations with only 2 unknowns. So we plug in 2 in the second and in the third equation. If we plug in 2 in the second equation, 3 times 2 is 6, so we have 6 minus b plus 2c equals 2. And in the last equation, if we plug in 2, 2 times 2 is 4 plus 2b plus c equals 1. If we simplify this, we have negative b plus 2c equals 2 minus 6 would be negative 4, and 2b plus c equals 1 minus 4, negative 3. So let me rewrite these equations here. Negative b plus 2c is negative 4, and 2b plus c equals negative 3. From here, to find b and c, you can use elimination method or substitution method. It's completely up to you. Here I prefer to multiply the first equation by a 2. If I multiply both sides by 2, then I have negative 2b plus 4c equals negative 8. And we keep the second equation. Now, if we add this equation to this equation, if we add left side to the left side and right side to the right side, you can see that we get 4c plus c, 5c. Attention, the b's cancel each other. Negative 2b plus 2b is 0. So we have just 5c equals negative 11. So from here, c is negative 11 over 5. Now that we have the value of c, we can substitute this value, for example, in this equation to find the value of b. Then we have 2b minus 11 over 5 equals negative 3. So 2b equals 11 over 5 minus 3. 2b equals 11 over 5 minus 3 is basically 11 over 5 minus 15 over 5 equals negative 4 over 5. So this equals negative 4 over 5. And so b is negative 4 over 10 or negative 2 over 5. So we know the value of a, value of b, and value of c, and we can put those values here. A is 2, so we have 2 over x. B is negative 2 over 5, so plus negative 2 over 5 all over x plus 2, and finally c was negative 11 over 5, so negative 11 over 5 all over 2x minus 1. Now let me show you the other method that we can use for finding ABC. When we write the partial fraction decomposition form, after we multiplied both sides of this equation by this denominator and we got this new equation without the denominator, then we can plug in some numbers for x that can help us to find ABC without solving any system of equation. Because solving system of equation for some students is challenging and they possibly make mistakes. Maybe this method is easier for them. But what special numbers we have to plug in for x? Because if you choose random numbers for x and you plug in, it's not so helpful. How we choose those numbers? We choose those numbers by looking at these denominators that we have here. Here we have x, x plus 2 and 2x minus 1. We choose values for x that makes these denominators 0. For example, what value of x makes this denominator 0? 0. If you plug in 0, then this denominator is 0. What value for x makes this denominator 0? Negative 2. So another number that can be helpful is negative 2. And finally, what value for x makes this denominator 0? If we set it equal to 0, from here simply x is 1/2. So 1/2 is another value that we will use to find a, b, c. But we start with 0. If we plug in 0 for x, then in the left side, this is 0 to the 2 is 0, 2 times 0 is 0, and this is negative 4. But why 0 is a good number? Attention, in this bracket, in this expression, and in this expression, we have x. Here we have x and x. When we plug in 0, these terms vanish. They get 0, because 0 times anything is 0. So, when we plug in 0 for x, only we have a as the unknown in the right side. So again, we plug in 0 for x, this expression would be 0, this expression also would be 0, so only we have this term. When we plug in 0 here in this bracket, 0 plus 2 is 2, 0 minus 1, 2 times 0 is 0, 0 minus 1 is negative 1. So we have a times 2 times negative 1. So we have negative 2a equals negative 4. And from here, a is 2. So simply we can find the value of a without writing any system of equation. And attention, this value is exactly same value as we got here for a. The next value that we try here for x is the number that makes the next denominator 0, and that value is negative 2. If we plug in negative 2 here, we have negative 2 to the 2 plus 2 times negative 2 minus 4. When we plug in negative 2, this would be 0. This is also 0. The reason is that we have this factor x plus 2. And when we plug in negative 2 plus 2 is 0. 0 times by anything is 0, and these terms vanish. So only we plug in negative 2 in this middle term. So we have b times negative 2. 2 times negative 2 is negative 4. Negative 4 minus 1 is negative 5. So we have basically negative 4, all of this is negative 4, equals 10b. And from here, b is negative 4 over 10 or negative 2 over 5. And this value is exactly same as the value that we got from the other method. What is the last value that we use here for x? 1/2. Because 1/2 is the number that makes this denominator 0. We plug in 1/2 for x. Because it's a fraction, substituting this number is a little challenging. 1/2 to the 2 would be 1 over 4. 2 times 1/2 is 1 minus 4. When we plug in 1/2, this is 0. And this is also 0. Attention, 2 times 1/2 is 1 minus 1 is 0. So we plug in 1/2 only in this part. c times 1/2 times 1/2 plus 2. If you do a simple calculation here, all of this would be negative 11 over 4. And if you do a simple calculation in the right side, this is 1/2 plus 2, 5 over 2. 5 over 2 times 1 over 2 is 5 over 4. C, and from here C would be negative 11 over 5. Simply C is this, divide by this, simplify it, and you get this value. And attention, this value is exactly same value as we got from the other method. It's up to you. You can use either method. Some students prefer to solve a system of equations. Some students prefer to use this method. It's optional to use which method. In this next example here, we want to write out form of the partial fraction decomposition for the given function, but we don't want to involve in finding the values of the coefficient. Just we want to write the format of the partial fraction decomposition. First, always we check that the degree of numerator is less than the degree of denominator. Because here the degree of numerator is 1, the degree of denominator is 2. If you wonder why the degree of denominator is 2, because attention, if you multiply these two brackets by each other, you have 2x times by a negative x, and then you get x to the 2. A term with x to the 2. So the degree of denominator is bigger than the numerator, so we don't have any long division to do here. We are ready to write the partial fraction decomposition form for this function. Basically, because we have two factor here, so in the partial fraction decomposition form, we have two fractions, one with 2x plus 1 in the denominator and 1 3 minus x. And we put two unknowns a, b in the numerator. For the next one, the denominator is not factored. So first, we factor the denominator. If we factor the denominator, we can write it as x times x2 minus 4. But x2 minus 4 can be written as x minus 2 times x plus 2. So the denominator is basically three factor, x, x minus 2, and x plus 2. And in the numerator we put the unknowns a, b, c. So this is the form of partial decomposition for this fraction, x2 minus x plus 4. In the next example, we notice that the degree of numerator is equal to the degree of denominator. When the degree of numerator equals or bigger than the degree of denominator, we have to do the long division first to make the degree of numerator less than the degree of denominator. So first we do the long division here. So x to the 2 plus 2x plus 4 divide by x to the 2 minus 2x minus 8. x2 divide by x2 would be 1. We multiply 1 in this expression, then we have x to the 2 minus 2x minus 8. We subtract this from this. For some students, when they want to subtract, it's a little confusing. Maybe you find this easier for yourself to change the sign of everything to the opposite sign and then add this to this. So instead of subtracting second equation from the first equation, you can change the sign of the second equation and then add it. So I mean, you can, what is coefficient of x to the 2 here? It's positive 1. You can make it negative. So you make this negative, you make this positive, and you make this positive. Now we add this to this. Negative x2 to plus x2 is 0, so 0. 2x plus 2x would be 4x. 8 plus 4 would be 12. So we change the sign of the second equation, and instead of subtracting, we added the second equation to the first equation. And this is our remainder. This is our remainder that we have from the long division. And we do not continue the long division anymore because the degree of remainder is less than the polynomial that we have here. The degree of remainder is 1, but the degree of this is 2. But what we have to do here, when we divided this polynomial by this polynomial, the quotient is 1, so this equals 1 plus remainder, which is 4x plus 12 all over x2 minus 2x minus 8. Now we have a polynomial in numerator that its degree is less than the denominator. Now we can continue and write the partial fraction decomposition form for this, and it would be in this form. Attention, this denominator can be factored as x minus 4 times x plus 2, and so we have x minus 4 as one fraction and x plus 2 as the denominator of the other fraction, and in the numerator we put a and b. Don't forget to put this 1 in your answer. So finally, the partial fraction decomposition form for this rational function that we had in the beginning, for this function here, the decomposition is in this form: 1 plus a over x minus 4 plus b over x plus 2. This is the partial fraction decomposition form. So first do long division. After numerator degree is less than the denominator, you can do partial fraction decomposition. In the next example also we have similar situation. The degree of numerator is bigger than the degree of denominator, so first we have to do the long division. So x to the 3 minus x plus 1 divided by x2 minus x minus 6. X to the 3 divided by x to the 2 is x. We multiply x, then we have x to the 3 minus x to the 2 minus 6x. Again here we have to subtract the second equation, second polynomial from the first polynomial, but if it's confusing for you, the subtraction, you can change the sign: negative, positive, positive, and add these two polynomials to each other. When we add these two, it's 0. Negative x plus x2 plus 6x plus 1. So basically we have x to the 2. 6x minus x would be 5x plus 1. Still we can continue the division. X to the 2 divided by x to the 2 is 1. We multiply 1, then we have x to the 2 minus x minus 6. We change the sign to negative, positive, positive. We add these two. This cancels with this. We have 6x plus 7. So this is our remainder. So when we do the division, the answer is x plus 1 plus 6x plus 7 all over x to the 2 minus x minus 6. This can be factored as x minus 3 times x plus 2. So the answer for this would be x plus 1 plus a over x minus 3 plus b over x plus 2. This is the partial fraction decomposition form for this rational function. I hope by watching this video you have learned a little more about partial fraction decomposition. If you want to learn more about this topic and you want to learn other cases for partial fraction decomposition, watch my next videos in this regard. I have many other videos about this topic. Please subscribe in my channel and see you in the next videos.